So for this one, you should have drawn an isosceles triangle. And the key to here is remembering from middle school that isosceles means that two of the sides are the same, right? Are the same or equal. So I've gone ahead and I've labeled these two sides of my isosceles triangle as 11 because my two sides are 11. And the base is 18. Now the question says, well, let's approximate the area. Let's approximate the area of this right triangle, of this triangle rather. And so that's your first little question there is, well, I can't actually find the area of this triangle because I don't know the height. I don't know what the height of this triangle is. If you remember, the area of a triangle is base times height divided by 2. That's how you find the area of a right triangle, or of any triangle really. But we need to know the actual height because the height is not 11. So the only way to figure out what this height is actually to draw it in. So I'm going to go ahead and draw my height straight down. You take it from the very top of the triangle and you draw that straight down to the base of the triangle. And then what this actually just did was it created a right triangle for me, right? So again, I'll highlight this one here off to the side. It creates a right triangle where we now have a hypotenuse of 11. We have this height that we don't know. And then the question is, well, what is this side, right? What's this side right here? Could we figure out a way to find this side right here? Well, it's actually not as hard as you think. Because this is an isosceles triangle, and this only works when it's isosceles, and when you draw this line straight down through, it hits the base smack dab in the middle. So if you've hit it smack dab in the middle, what you basically just did was this is now 9 and this is 9, right? So that allows us to find that additional side with not doing nothing other than just drawing in our height. That only works when it's isosceles. Don't go drawing crazy lines and then say we'll cut it in half. Well, only if it's isosceles. So now we have our hypotenuse, our C value is 11, and our A or B value is 9. So I went ahead and did the math over here to the side. So if we go ahead and set it up, we have x squared plus 9 squared equals 11 squared. Subtract the 9 squared over, so that's 121 minus 81, you get 40. And so now the height of our triangle is approximately 6.3. So right here, the height of our triangle, okay, is approximately 6.3 inches, 6.3 inches. And I guarantee if you're taking any type of test, 6.3 might be one of your answer choices, but it's not our answer. Because again, don't forget, the very beginning, it said we are trying to find the area. So to try to find the area, let's go ahead and plug in. Our base, what is the base of our triangle? Well, the base of our triangle is still 18. Remember, we're trying to find the area of the whole triangle, so it's still 18. So 18 times the height of our triangle, we just found that, 6.3, and we divide the entire thing by 2. So if we plug this into our calculator, we multiply the top first if that's easier. So 18 times 6.3, and we divide that by 2, and we're left with approximately 56.7 inches squared. It's inches squared because this is the area of our right triangle. So hopefully that helps. Isosceles questions are quite common. So make sure you are comfortable drawing that right triangle and then creating the dimensions from it. For our next question, it's really important that we follow this visually here. Addison is standing in the middle of a really large field. And she's throwing a baseball, or he's throwing a baseball in a few different directions. So the very first thing, like we did on that previous question, is I would drop a point right here somewhere in the middle, okay? And then the first thing he does is he throws the first ball 20 yards straight out. So we're just going to say that this is 20 yards straight out. You don't have to draw the arrow necessarily. But if we draw that first ball 20 yards straight out, we'll draw a line and label it 20, right? From there, what it says is he turns 90 degrees to the right. So if we're facing this direction and we turn 90 degrees to the right, now we're going to be facing this direction, right? I'll get rid of those now, but just to help you visualize. So we turn 90 degrees to the right and we throw another ball 23 yards straight out. So this time we throw this direction, 23 yards straight out. He does it again. He turns another 90 degrees this direction, right? And when he turns that direction, he throws it 45 yards. So 45 yards all the way out to here, okay? So he's now thrown 3 different baseballs. And the question that he's trying to figure out is, like, all right, I got to go pick up the baseballs. What is the shortest distance he can walk to retrieve all 3? All right? And remember, he does not need to come back to his original spot. He doesn't need to come back here. He just starts there. So I want you to press pause in just a second. I want you to actually try it out. Do some experimenting. See if you could figure out what would be the shortest way. But before you do, you have to figure out a few distances. For example, just to make it abundantly clear, we are not about to, let's say we go here. We don't have to walk back and then go here. You know, it's not a matter of that. We can go here, or we could go this direction, or we could go the down, straight down. It's really up to you which direction you want to go. But you can also, so let's just say we do go this direction, you can also cut across, right? So we'd have to figure out, well, what is that? What is that distance? We could also go this direction. We could figure out what that distance is. So that's the first thing I want you to do. Press pause, do a couple different scenarios, and see if you want to discuss or figure out the quickest way to get all 3 of these. What I'm going to do is I'm going to first go the shortest distance possible. So I'm going to first walk that 20 yards. All right. But now I don't want to walk backwards on that same line I just walked on. I want to go from here to here. So I'm going to walk along this path. We need to figure out what that line is. No problem. Here's my A value. Here's my B value. This is my C value. I have a right triangle. So 20 squared plus 23 squared is going to equal C squared. Right? I'll just knock that out real quick. If we type that in the calculator, 20 squared plus 23 squared gives me 929. Okay, that's my C squared. Take the square root of 929, and we get approximately 30.5. So this distance here is about 30.5 yards, right? From there, I want to again walk straight this way, okay? So another right triangle, have my A, we'll call this A again, and we'll call this B again. This is still my B value here. So my new equation for this distance is going to be 45 squared. Oops, careful. 45 squared plus 23 squared equals my C squared. Okay, so let's plug that one in. 45 squared plus 23 squared. That gives me 2,554. Take the square root of that, and we are left with approximately 50.5 yards, right? 50.5 yards. So, last but not least, here's my quickest distance. See if you were the one if you figured this one out. My quickest distance, like we've said, is already to go this 20 yards here, and then 30.5 yards here, and then 50.5 here. I challenge you to see if you can find a quicker way. To me, that is the fastest way to get all 3 of the baseballs that we have thrown, right? So it's a really good practice of the Pythagorean theorem, and then it's also kind of good way to test yourself out and problem solve a problem like this. So if you have a time, I want you to try this challenge question. If you're feeling good, don't stress about it. But with this challenge question, what we're looking at here is a rectangle, and it says that the rectangle is 9 inches longer than it is wide. So anytime we were practicing this earlier in the school year, when it says 9 inches longer than it is wide, well, then that width is the same. Let me use a different color there. That width is not going to change. It's just our width. Our length, though, is the width plus 9. Since it was 9 inches longer than it is wide, that's our length there. And then last but not least, it says that the diagonal is 10 inches longer than the width. So our diagonal here is 10 inches longer than the width. So I'm going to write W plus 10. Now this actually challenges you to go to a whole other level because it creates an equation that's quite intricate. In order to find that W, this is the equation you're going to create. We're going to start with the red one. So that's A. So you notice it created a right triangle here, right? So my A value, we'll call this A, this will be B, and this is obviously C. So my A squared is W squared plus my B squared, now you got to put this in parentheses, is W plus 9 squared equals my C squared, in parentheses again, W plus 10 squared. Now, you don't actually know, some of you might, but you don't actually know how to simplify this. Don't go squaring things here just anyhow you want. There is a process behind it that you will learn in our polynomials unit, but I'm just going to quickly knock it out for you so you can see what it would actually be. This W squared stays the same. This portion is going to actually become W squared plus 18W plus 81 equals W squared plus 20W plus 100. So there is a process behind that. If you don't know it, don't worry about it. We need to combine some like terms and get the entire thing equal to 0. That's the only way we're going to be able to solve here. So if we combine these two like terms, but also subtract this W squared over, we're going to be left with 2W squared minus a W squared is just a W squared, right? Subtract this 20W over from him, so we're left with negative 2W, and subtract this 100 over from him, okay? And we're going to be left with, whoops, I wrote the wrong thing there, my bad, give me a second. All right, we're going to be left there with, how do I undo, right. Where was I? Subtract the 100. Yeah. So we're going to be left here with negative 19. Sorry about that. So undo it. Now it all equals 0, right? Because this cancels, cancels, cancels. And so it's at this stage in the game that looks pretty complex. And you actually won't know how to solve this until later on in the year. But it's going to be pretty cool to see how we can solve this type of equation. So I'll just kind of leave you in suspense. We're going to use something called the quadratic formula, or graphing, or factoring. In this case, this one's not going to factor, but it's pretty exciting to kind of see how these things come together. If you want some more practice on this, you can go to that link right there on your screen. There's plenty more to practice, but for now, I think you've got a really good, some good practice under your belt, and I think we're in good shape.